Welcome back to Decentralized Application Development Crashcasts. I'm Sheila, and as always, I'm joined by my co-host, Victor. Before we dive in, we'd love to hear from you. If you're enjoying our show, please take a moment to rate us on your favorite podcast platform. It really helps us reach more developers like you.
Absolutely, Sheila. Your feedback means the world to us. Now let's get started with today's topic. We're currently in Season 1, Chapter 4, exploring decentralized storage systems. Today we'll be discussing the Interplanetary File System, or IPFS for short.
Ooh, interplanetary file system sounds intriguing. But before we jump in, I've got a quiz question for our listeners. Here it is. In IPFS, how does the system know where to find a specific file? Is it by A, a traditional URL, B, a content hash, or C, a centralized database? Think about it, and we'll reveal the answer at the end of the episode.
That's an excellent question, Sheila. It really gets to the heart of how IPFS differs from traditional file systems. Listeners, while you ponder that, let me add that the answer might surprise you if you're used to thinking about files in terms of where they're stored, rather than what they contain.
Great point, Victor. Now, before we dive deeper, could you give us a brief explanation of what IPFS is and why it was created?
Certainly. IPFS, or Interplanetary File System, is a protocol and peer-to-peer network for storing and sharing data in a distributed file system. It was created to address some of the limitations of the traditional client-server model of the web, aiming to make the web faster, safer, and more open.
Interesting. So it's like a decentralized version of the Internet's file system? How does that work?
That's a good way to think about it, Sheila. At its core, IPFS uses something called content addressing. Instead of saying where a file is stored, which is how traditional URLs work, IPFS addresses data based on what it contains.
Content addressing sounds intriguing. Can you explain that a bit more?
Of course. Imagine a library where instead of organizing books by their location on a shelf, each book is identified by a unique code based on its content. If you have that code, you can find the book anywhere in the library or even in other libraries. That's similar to how IPFS works with files.
Oh, I see. So if I understand correctly, in IPFS, each file gets a unique identifier based on its content, and that's how the system keeps track of it?
Exactly. This unique identifier is actually a cryptographic hash of the content. When you request a file on IPFS, you're asking for it by this content hash, not by where it's stored.
That's fascinating. But wait, if files are identified by their content, how does the system know where to find them in the network?
Great question. This is where the distributed nature of IPFS comes in. IPFS uses a distributed hash table, or DHT, to keep track of which peers have which content. When you request a file, the network consults this DHT to find peers that have the content you're looking for.
I see. So it's like a decentralized phone book for content? That's clever. But how does the actual data transfer happen once a peer with the content is found?
That's where the BitSwap protocol comes in. BitSwap is IPFS's data trading module. It's a bit like BitTorrent, where peers exchange blocks of data. Each peer keeps a want list of blocks it's looking for and shares what it has with others.
This all sounds really powerful, Victor. What are some of the advantages of using IPFS over traditional file systems?
There are several key advantages, Sheila. First, it's more efficient. Since the same file can be retrieved from multiple sources, it can lead to faster downloads. Second, it's more resilient. There's no single point of failure, as files are distributed across the network. Third, it helps with versioning and deduplication of data. And finally, it can work offline or in poor network conditions, which is great for areas with limited internet access.
Those are impressive benefits. Are there any real-world implementations of IPFS we can talk about?
Absolutely. One notable example is Filecoin, a decentralized storage network built on top of IPFS. It allows users to rent out their spare hard drive space and get paid in cryptocurrency. Another interesting use case is in the realm of content distribution. Some websites use IPFS to distribute their content, making them more resistant to censorship and server outages.
That's really cool. but I imagine there must be some challenges or limitations to IPFS as well. What are some of those?
You're right, Sheila. While IPFS is powerful, it's not without its challenges. One major issue is content persistence. Since IPFS relies on peers to host content, if no one is hosting a particular file, it becomes unavailable. There's also the challenge of privacy, as content on IPFS is public by default. And while IPFS can be faster in some cases, it can also be slower for accessing rarely requested content.
Those are important considerations. It seems like IPFS is a powerful tool, but developers need to understand its strengths and limitations to use it effectively.
Absolutely. And speaking of understanding IPFS, here's a fun fact. The interplanetary in IPFS isn't just a catchy name. It was chosen because the system is designed to work across long distances and even in space. The creators envisioned a file system that could work for future interplanetary communication.
That's amazing. Who knew we were discussing a potentially spacefaring file system? Now, before we wrap up, let's get back to our quiz question. Victor, would you like to reveal the answer?
Certainly. The correct answer is B, a content hash. As we discussed, IPFS uses content addressing, where files are identified and located based on their content rather than their location.
Thank you, Victor. To summarize what we've learned today, IPFS is a distributed file system that uses content addressing to identify and locate files. It offers advantages like efficiency, resilience, and censorship resistance, but also comes with challenges like content persistence and privacy considerations. It's being used in real-world applications like Filecoin and content distribution networks.
Excellent summary, Sheila. I hope our listeners found this deep dive into IPFS enlightening. Remember, understanding technologies like IPFS is crucial as we move towards more decentralized internet architectures.
Absolutely. And to our listeners, we'd love to hear your thoughts on IPFS and how you might use it in your projects. Don't forget to visit crashcasts.com and join our Discord community to continue the conversation. If you're enjoying the show, please consider supporting us on Patreon, and don't forget to subscribe and rate the podcast. Your support helps us keep bringing you in-depth content on decentralized application development. Until next time, happy coding!